Hi, welcome to episode 5 of my Figura tutorial series. In this episode, I'm going to be explaining advanced parent types, which are the blockbench keywords. Now, real quick, I just want to apologize about my break. Stuff happened, as I'm sure you're aware. I plan to continue the series and keep it up to date. First things first, let's look at the advanced parent types. Now, in the in-game docs, Figura actually lists all these parent types. So if I go Figura, docs, and then we go to enums, you can see on here it's a list of basically a bunch of different lists. If we go to parent types, you can see here's all of Figura's parent types, all the blockbench keywords. There's all the simple ones we've already looked at, like the head, the body, all the arms, the legs, capes, elytra, etc. There's also all the pivots, like the spyglass, the parrot, all that, all the armor stuff as well. But there's also some extra things which are really fancy. The first one here is a world. What world does is it takes your model part and it renders it relative to the world. It also makes it render in first person. I'm going to need a model part to play with, so I'm going to make a new generic model. I'm going to call this Figura. Make this bright green. I'm clearly very amazing at texturing. Perfect. There we go. So we have our part now. So if we change this part to be world, save it, it's gone. Except something you might not notice. It's still on screen, just it's a little off in the distance. So yeah, you can see now our part is relative to the world. So the reason it's spawned up here is because this is 0, 0, 0. That's like, you know, the 0, 0 between 4 blocks. The reason it's up here is because 0, 0, which is, you know, this position right here. I don't know if that's too easy to see. This position. That's 0, 0 in the Minecraft world. This position. Every blockbench coordinate here, which is like the pixels, is 1 pixel in game. So if you can see it's like here, then it's 1 over. That means 16 pixels is a Minecraft block. So to move it a block over, you'd have to move it 16 over, and then it'd be on the next block. Now I've just joined another account and uploaded my avatar to quickly show you something. So for other people by default, if you look away from the, you know, main avatar, like from the entity, this world part will disappear and will only appear when the player entity is on screen. Now what this is just normal culling. Although this is a world parent type and it appears over here on these blocks, it's still a part of the player model. It's still part of the entity. And so when the player isn't being rendered, it doesn't get rendered either. However, Figura does have an override. If you go into the trust settings and then turn on render off screen, it will render the player always. So yeah, even if the player is off screen, you'll still be able to see the model part. This does also mean though that that model is also being rendered even when I'm not looking at it, and so that is potentially a performance issue. By default on high, render off screen is enabled. Now even if you have render off screen on, if the player entity doesn't exist, that model part can't exist either. So if I quickly go away, and there, I've exited render distance. So yeah, since my player entity here doesn't exist for this client, it can no longer render the world part. The moment I enter render distance again, it appears again. Next, you might want to change the position of this to somewhere else in the world rather than 0, 0. Of course, you could do this by moving your model part and just doing get and check until you're at your position, but oh my god, that would be the most painful thing ever, especially if you're moving at thousands of blocks. So of course the best way to do it is with scripting. Just of course models and then floor galore. The pause, and of course we need our position, so I better actually find somewhere to go. I'll go to the top of this tree. If you somehow don't already know this, you can hit F3 to see your coordinates. And in the corner here is the coordinates of the current block you're looking at. So just write those down. And if you paste this in, you'll notice that it's barely moved at all. And that's because, of course, I've moved it by block bench units. You need to move it by world units. That, of course, is 16 times larger. You could either times it by 16, which you could either do it like this, and that'd move it. Or you can get fancy and use the vectors API, which I don't think I've actually properly explained yet. But if you just put vector in here and then times that by 16, it will move here. To move it to the center of the block, you could either move it in block bench, or you can literally just add 0.5 on here, and it'll move it. As you can imagine, you can use this like any other script. You can update this coordinate, you know, in tick or render. So like, yeah, you could use the player API to get your current position and teleport it to you, or anything you want really. Next up after world, we have HUD, which renders your model part inside the GUI itself. So yeah, like the GUI, you know, where you have your inventory, your hotbar, everything. It's a GUI head. Yeah. So, I'm going to rename this to HUD. You can also call it GUI, both work. Anything listed here works. You could call it heads up display if you want. And now that I've updated it, it's gone. Completely, it seems. It's not actually, it's just where we've got it positioned. So just like how 00 in Blockbench is 00 in the world for the world parent type, 00 in Blockbench is 00 in the HUD, which is up here in the top left hand of the screen. When you're working with a HUD, you need to make sure your orientation is correct. If you look in here, you see N, which is north. That's the direction your avatar faces. You need to make sure you're facing in the opposite direction, so south. That is obviously like the face of your avatar. Since 00 is the top of the screen, your screen will extend out like this, if that makes sense. So as you can imagine, our model part here is outside of the screen. To fix this, you can simply just move your model part into the screen. And if I go in game now, you can see up in the corner, we have a little face. Now the rendering here is orthographic, so like if I was to rotate like this, you can see it is 3D, it isn't 2D. That's basically this kind of projection here, where no matter how far away you are or close you are, it will still look the same. And you can see from this view, it's basically, it'll look exactly like this. So now in terms of scale, yes, obviously, it's really tiny on my screen. You can barely see it. So let me just change my GUI scale. On GUI scale 1, one Blockbench cube is 1 pixel on the screen. So it's very, very tiny. Or I guess like one Blockbench coordinate is probably the better name. Now if I change this to GUI scale 2, the best GUI scale, you'll notice that one Blockbench cube is 4 pixels on the screen and a little 2x2 grid. And then this will be the same for GUI scale 3. It's a 3x3 grid. And GUI scale 4, 4x4. Now, of course, you might not be happy with that scale, you know. You might want a larger pixel density, but not want to have to change your GUI scale. There's 2 ways you can do this, really. First one is, of course, just change the size in Blockbench itself. If you're using Box UV when you start out, you can just start with a higher texture resolution, or if you want, you can, you know, change it later, but that can be a whole mess trying to get the UV to match up again. Using per face is probably just easier in this kind of situation though. Personally though, I'm not a fan of doing this because everything ends up just being really big and hard to manage, and I like everything being within the grid. The way I like handling it is scaling it with scripting. Because yeah, you can obviously just do set scale with the models API, and I think it works a lot easier. So it's just, you know, models dot your model path, so floor galore. And I'll just make it like 16 times bigger. Save this, and you can see it's suddenly a lot bigger. Changing the position like this though obviously is a bit weird, because like it's scaling basically from the pivot point. To scale your position, which is something I like being able to do as well, you can literally just move your pivot point back to 0, 0 whenever you make a movement, and you can see it updates correctly. So I could move this over here, and then move my pivot point back, save that, and it's moved correctly. Another thing you can notice is it's currently bound to the left-hand corner of the screen, which might not be what you want. What if you wanted it on one of these other corners or in the center of the screen? So to adjust your part to these positions, you'll have to use something in the client API called get scaled window size. If I just go Figura, docs, globals, client API, get scaled window size, you can see it will return the window size as basically Minecraft's GUI units. That basically just means it'll work with the GUI scale. You can, if you want, also get the pixels, but it just means you'll have to also get the GUI scale and times it, so it's kind of pointless. Just use this one. So yeah, you can see if I log this, it will get me my current resolution, and it'll change depending on whatever my resolution is. In terms of the Minecraft GUI units, I think the most organized and efficient way you can do this is, of course, first make a local variable. That way we don't have to be retrieving the value multiple times and wasting instructions. Local size equals that. And also, because of a quirk of the way like Blockbench positioning works, you also need to make these values negative. So just like invert them. It's not a big deal, it's just something you have to keep in mind. I think just inverting it here in the local variable is the easiest way of doing that. Okay, and then to actually set the position, of course, first you're going to want your model path, and then set pos. Then you have your X, Y, and Z. That's, you know, same as Blockbench in this orientation. X is this way, left and right. Y is up and down. And Z is back and forth, which you won't be able to see. I'll explain what that's useful for later. So if I wanted this to be on the top right of the screen, I would want to change the X. So I'd grab my X value from my size. So size.x and then 0, 0. This makes it disappear again, and that's because of our placement, because now the screen is like here. So I'll move this over, and I'll fix the pivot point, and there we go. Now it's bound to the right hand side of the screen, although you'll notice it isn't correctly updating. That's of course because this is only executing once at the beginning of our script, so when we save it, it'll fix and then it'll never update it again. So I'll just put this inside a render event, and now you can see it is correctly updating. As you can imagine, if you wanted this to be at the bottom hand of the screen, it'd be exactly the same. Make this Y and then update this, and there you go, and be the same for the left hand. And again, you can adjust the position however you like, just make sure you're resetting the pivot point. If you wanted this to be centered, that's also extremely easy. Just divide it by 2, adjust the pivot point to be like in the center of your part, like this, and there you go. Now it'll stick to the center of the screen. Same thing again for, you know, making it in the center of the screen. Now again for Z, you won't really see this on the screen. What this is it's like the layer that it's rendering on, because all the HUD elements are actually being rendered in 3D. That's the way it's done in most games, actually. If I were to change this to like -1000, oh, too much, -900, you can see it renders above more stuff. And if I change this to 900, it renders behind more stuff. This is honestly just a case of play with the values until it's in front or behind of whatever you want it to be. Just keep in mind there is a clipping plane, so you will reach a point where you can't see it anymore, which is what I did before. And yeah, of course, HUD parts render in first and third person, and if you hit F1, it'll disappear because, you know, it's part of the HUD. So the next parent type we have is camera, and that will make it so your model part will face towards the player camera. I think the easiest way to explain this is to just show it. I'll move this out of the way a bit, and yep. So now you can see wherever I'm looking, it's rotating. Now you might get this confused with the head, but no, it's actually facing the camera itself. That also applies to the wardrobe screen as well, which is pretty funny. If I join my alt again, you can see this also applies for other players. It'll always face the camera. It's kind of creepy. There's not much more to it, really. If you want, you could make it a world part, so it'd be like inside the world and always watching. That'd be creepy. Or you could do the same thing with the player skull, which is the next thing I want to explain. So Figura actually, you know, replaces your vanilla player head with the one from your avatar, which is so cool. It's the coolest thing ever. Obviously, these model parts are parented to the world. They'll load even if your entity isn't in your render distance or even in the game. They can run scripts and all sorts. Player heads are really cool. Now, by default, it grabs your player head just from, your head. If I were to delete this, it wouldn't have a head for me to go to. Hold on, there we go. And so it'd just resort to my vanilla one. Same if I just hide it as well. But you can actually specify a custom part to be your head. So let me move this over here. If I just name this skull, if I save this, go in game, now it has replaced my skull with the little creature. Now, of course, you can do a lot more than just, choose what model goes to your player skull. Figura has a special render event, which specifically gives you information on things like the position, the block state, where the playhead's being rendered, all sorts of stuff, so that you can do some really creative things with playheads. I just show you in the docs. It's Figura, docs, globals, events API, since, it's a custom event, and then skull render. It's like a version of the render event, so it runs every single frame, but it specifically runs for every single skull. The normal render event just has delta, but this also has like the block state of the block that's being rendered, so you can get like the coordinates, its rotation, all that kind of stuff. To create this function, literally just go function events.skull render and a log block state. And now you can see it's telling me all the different block states. These 4 here would be the block states for these 4 heads in the world, and then the 2 ones that are nil would be one that's being rendered in my inventory, and one that's being rendered in my hand here. That's a little hard to see, this one. With this, you can do some really creative things. Like, for example, I have made a working piano. Don't really have the time to explain how it works right now, but you can get that on my GitHub if you want. And a different community member, Ep.5, has made a lot of different things on their playhead, but I'm going to show Doom here. It's literally just like 3D rendering. I don't even understand how this is done. So yeah, you can do some really creative things with playheads, as you can see. In terms of replacing like the head, portrait is basically the same thing, but for the portrait that appears in the tab list and also in the permissions screen. So if in Blockbench I just replace this with portrait, save, look in the tab list, you can see now it's replaced that with a little creature. Same thing on here. And just like with the HUD, it's like isometric, so you can rotate it however you like, and it's still 3D. This next one's a funny one, arrow. It will replace the model of your arrows. So, arrow, save. Let me grab a bow. As you can see, my arrows are now the little creature. They fly through the air. Oh my god, this is amazing. Oh, I love Figura. It's the best mod ever. Now, just like Skull, the arrow parent type also has a render event. That'll give you some information and allow you to customize some things for your arrows. If I just go /Figura, docs, globals, events API, arrow render. You can see the function here. You have your 2 arguments, you have delta, and then you have the arrow entity itself. That's part of the entity API. You can see you can return true to stop the arrow from rendering if you want. You can do all sorts. And of course, this will run once for each arrow, so you can customize each and every arrow. If we just go to the entity API here, you can see this is the kind of stuff. You can get all this information from the arrow. I made a quick example over here where I just log the arrow entity itself. So if I shoot an arrow, you can see it's returning the arrow entity. And so if I were just to go arrow entity : get pause, save this, now it returns the position of all my arrows. Alright, after this is the item parent type. The item parent type replaces the model or texture, I guess, in your hand. So that's both for you in first person and for what everyone else sees in third person. This is good if you wanted, say, a custom sword or something like that. Now, yeah, it doesn't replace the textures in your inventory. You'll have to use like a resource pack for that. It is, at the end of the day, your own client, so that doesn't really matter too much. So, yep, first, of course, we want to change this to item. And when we do this, it is now just completely gone. The item parent type is a little more advanced. You need to do some scripting stuff to make it work. First thing you need to do is go into your script, and you need to access the item render event. Now, this is an event just like, tick or render, but it instead runs for whatever item you have held in your hand. So, I'm just going to go function events.item render, and then I'm just going to return the path to my model part. So models.floglob.item. Oops, it's a P. There we go. Now the floglob is our held item for every single item, and it appears like that in first person as well. Of course, if you throw it on the ground, it becomes a normal item, and yeah, it doesn't appear like that in your inventory. So, of course, you might not want to replace every single item with your model, understandably. So to do that, you have to do scripting to check, what the item is, and then return the corresponding model part. If we look here in the item render event, you can see it returns the item. So if I log item, now you can see whenever we hold something, it will log that item as like user data. Now I haven't exactly showed this yet, but inside the world API, you can access item stack information, and from this you can get a whole bunch of information about an item, whether that be the name, the ID, its damage, if it's enchantable. So yeah, you can check whatever one of these you want, really. In this case, I'm just going to get the ID, which would be this here. So that'll log the ID as a string. Then I'm going to use find, and I'm going to search for sword. Make this an if statement. Now it'll only work if it's got sword in the name. So then that'll work for any sword. You could also do something like this, where if you just check if it has that as the name. That could also be easier if you're looking for a specific item. And again, of course, you can use the item stack information in the world API to access more information. And one final thing, you can also modify what parent type a part is using. This is with the setParentType function in the model part API. That obviously just sets the parent type of your model part. Pretty simple. So say I had my parent type set to arrow, because I typed arrow in Blockbench, and you can see it sets it to arrow. But I actually wanted it to be set to the camera, so I could go models.floglob.arrow set parent type camera, and you can see now it switched it. You can also set it to nil, and then it will clear it from having a parent type. That's pretty niche and rare use case, but it's useful to know about. And that's it. The rest are just pivot points and stuff that I've already explained. Thank you so much for watching this episode, and hopefully it wasn't too information dense. What are those pigs? Okay. Yeah, I just had a lot to get through. I hope to see you in the next episode. Thank you for watching.